Hey math kids, today we're going to talk about Radian Measure, and we're just going to jump right into it. So for lack of a better explanation, if we have a table, and my computer's going slow for some reason. Okay, so if we have a table, this is not a very good picture of a table, but you can use your imagination. Okay, if we have a table, we can measure that table from here to here, like the length of that table. We can measure it as, we can measure it in feet, we can measure it in meters, we can measure it in inches, we can measure it in centimeters, etc. So we can measure it in a lot of different things. It means the same length, but we'll get a different number attached to it, whether we do it in feet or meters or inches or centimeters or miles or whatever we want to do it. So that's really all radians is, but with an angle. So if I have an angle, or let's say a triangle, and I'm looking at this angle, I can measure that, and I can say, okay, that's 30 degrees, right? When we're in radians, we use pi as a part of it, and an entire circle is 2 pi, where in degrees it's 360. Okay, so if we think of this 30-degree angle, we can think of that being like 1/12 of the entire circle. And so if we do 1/12 of 2 pi, and then we reduce that, it's pi over 6. And so pi over 6 is the same thing as 30 degrees. It's just one's measured in radians and one is measured in degrees. Now, what a radian actually is, like the definition of it. If we have a sector of a circle, when the radius becomes the same length as the arc length, so if the amount we have to rotate to create a slice of pizza where the length is the same length as the crust, that measurement right there is 1 radian. Okay, you don't necessarily need to remember that, but just in case you were, wondering what is a radian. Okay, now in your book, we're going to do some of the examples. It says to convert 45 degrees into radians and leave it in terms of pi. Now what we do, remember half a circle is going to be pi, and half a circle in degrees is 180. Now we have degrees up here, so we want degrees on the bottom, so those cancel, and so we're going to multiply by pi over 180. Now if we reduce 180 and 45, we end up with pi over 4. Okay? So pi fourths is the same thing as 45 degrees. Okay, now we want to go the other way. Oh, never mind, sorry. We're the same way. So we're going from degrees into radians again. So we use this again, pi over 180. This time they want us to do it using a decimal. And so let's see. Pull up the calculator. We do 126.5 times pi divided by 180. Hit enter, and we get 2.207. Okay, and if we round that to 3 significant figures like IB asks us to, it's going to be 2.21 radians. So once again, this angle measured in degrees is the same thing as this angle measured in radians. Just like 12 inches is 1 foot, those numbers are different, but the units make them the same length. Okay, now we're going to go the other direction. We're going to convert 5 pi 6 into degrees, and then we're going to do 0.638 radians into degrees. Now, because our units are radians, we're going to flip that fraction upside down that we were using. And so I'm going to now multiply this by 180 over pi. And one way that you can think about that is we have pi on top, so we need pi on the bottom to cancel it, because typically when we have degree measures, we don't have pi in our answer. And so cancel those. We do 180 times pi divided by 6. So 180 times pi divided by 6. And if we do 3 significant figures, that's 94.2. And I did the wrong multiplication. That's why I got the wrong answer. Okay, sorry. So it's 180 times 5 divided by 6. All right, so 150. So 150 degrees. Okay, once again, 5 pi 6 radians is the same thing as 150 degrees. Okay, similar process. We're going to say 180 over pi. This time there's not a pi to cancel, but we still want to kind of think of it in that way. Then we just plug this in. 180 times 0.638. Divide that by pi. And we get 36.6 if we round to 3 significant figures. Okay, if you need additional help, please come to Math Lab. Until then, calculator.